When we consider value at risk, we need to think about how much money can we make and lose in our portfolio? What are the drivers of making and losing money in a portfolio? It's easiest to think about that if we put a trade into our portfolio. So I am going to sell 1,000 put options, strike of 100, maturity in 1 year. So this is my portfolio. If I think broadly about this portfolio, we can think about what are the risk factors. What are the Greeks that we have? We have a delta, it's a positive 363, a gamma, negative 17.85, a vega, negative 375, a rho, 407, and a theta, 5.31. So what does that mean? The delta and gamma are related to changes in the asset price. So if this is our asset price, if the change in the asset price for small movements, if the price goes up, the delta is what we're going to make money from our delta. Not quite as much money because of the gamma, but we're generally going to make money. Volatility, we're short options. The vega is negative, so if volatility increases, we lose money. Volatility decreases, we make money. We've got a rho, that's our profit and loss due to a change in interest rates. So when interest rates increase, we make money. And theta is the change of time. We're not going to worry about the theta for just a moment. So basically, as the asset moves around, if the stock goes up, we make money. The stock goes down, we lose money. Volatility increases, we lose money. Volatility decreases, we make money. Interest rates go up, we make money. Interest rates go down, we lose money. So those are our three variables. If we think about what might happen in the world, those are the three things that affect this portfolio. So we have the asset price, we have the volatility of that asset price, and we have our interest rates. Value at risk is going to work as follows. We are going to simulate what might happen to those parameters: asset price, volatility, and interest rate. We're going to make an assumption about those parameters in this spreadsheet, which is they are all log normally distributed. Log normally distributed means that returns are normally distributed. We make the returns normally distributed, and we can assign a correlation between them. So for every parameter, we need a volatility of that parameter, and we need some correlation between them. So this spreadsheet, when it calculates value at risk, is going to simulate our variables and see what happens. It's going to use something called a Monte Carlo simulation, which means that simply it's going to simulate the variables, it's going to re-evaluate the portfolio according to those changes, and it's going to keep track of this. It's going to do this over and over again. And again, value at risk works off of a percentile. And so in our case, the percentile might be the 95th percentile. So it's going to look at all of those possible outcomes. It's going to choose the 95th percentile, worst one, and that's going to be our value at risk. So next we will talk about how that works in the spreadsheet. So if I go to my value at risk tab in the spreadsheet, you will see the parameters, the underlying asset, the volatility of that underlying asset, and the interest rate. They're all log normally distributed, so we have to specify a volatility of each of them. The volatility of the underlying, the volatility of the volatility, and the volatility of the interest rates. And then we also have to specify how those changes, how those parameters are correlated. So right now in my spreadsheet, I have a 60% correlation, positive, between the underlying asset and the volatility of the underlying asset. Typically, for a stock market, we expect this to be negative, although that does not have to be the case. We have a volatility between the underlying asset and the interest rate. In this case, is 0%. And we have a correlation between the underlying asset and the interest rate, 0. And we have a correlation between the volatility of the asset and the interest rate, again set to 0. Finally, in our spreadsheet, we have a couple more inputs. We have a percentile what value at risk are we interested in, a number of days, so this is the 1 day 95th percentile value at risk that we're going to compute, and a number of simulations. The more simulations you do, the more accurately you can calculate this number, but it takes longer. Often we will run, say, 10,000 simulations to get an approximate number of what the value at risk should be. The bottom part of the spreadsheet allows us to see how this sampling works. Every time we recalculate the spreadsheet, we see a new sample, spot, volatility of the spot, risk-free interest rate. So if I recalculate the spreadsheet, a possible sample of values given these distribution assumptions in 1 day would be the spots 100.37, volatility 20.88, interest rates 4.86. We can recalculate that, 98.51, 19.61, 4.58. Again, we've made an assumption in this version that the underlying asset and the volatility of the underlying asset is about 60% correlated, which means that if the stock goes up, in general, so does the volatility, or if the stock goes down, then in general, so does the volatility. So we set our number of simulations, we set our parameters, we set the market information for our simulation, we click the button, and it will simulate the value at risk. So I'm going to go ahead and run our simulation, again, making this assumption that the correlation between the underlying asset and the volatility of the underlying asset is 60%. I will pause the video because this might take a little while. We are doing 100,000 simulations. I would guess that's about a 5-6 minute simulation. So I'll click Simulate. You'll see at the bottom of the tab, it will tell you it's running simulations. It will tell you which simulation it's on, and that will work until we get to 100,000. So I'm going to pause the video right now, and we'll bring it back once this simulation is completed.